stay with me until the very end of this video, because what you're about to hear might completely change the way you think about our place in the universe. For decades, scientists have searched the skies for signs of life. But today, we're closer than ever to answering one of humanity's oldest questions. Where will we find extraterrestrial life first? And the answer might not be where you expect. So don't blink, don't click away, because the next few minutes will take you on a journey through the most promising places in the cosmos where alien life could already be hiding. Imagine waking up tomorrow to the headline, "Life Found Beyond Earth." Where would that discovery come from? A distant exoplanet, a hidden ocean beneath an icy moon, a strange chemical signal drifting through space. The truth is, we're on the edge of multiple breakthroughs at once, and each one could reveal life in a completely different form. Some of these worlds might host familiar Earth-like biology. Others could harbor life so alien that we might not even recognize it at first. But all of them share one thing. They are real, they are within reach, and we are studying them right now. Let's start close to home, because the first place we might find extraterrestrial life isn't light years away. It could be right here in our own solar system. Beneath the icy crusts of moons like Europa and Enceladus, there are vast oceans of liquid water. Not small lakes, not shallow seas, but entire global oceans, deeper than anything on Earth. These oceans are kept warm by tidal forces, the constant gravitational stretching and squeezing from their parent planets. That heat creates hydrothermal vents on the ocean floors, just like the ones on Earth, where life thrives in complete darkness. On our planet, these vents are home to ecosystems that don't rely on sunlight at all. They feed on chemistry, not light. And if life can do that here, it could do it there. Europa, one of Jupiter's moons, is especially promising. Its icy shell is cracked and streaked, suggesting movement and exchange between the surface and the ocean below. Even more exciting, the Hubble Space Telescope has detected plumes of water vapor erupting from its surface. That means we might be able to sample the ocean without even drilling through the ice. Just fly a spacecraft through the plume and analyze the droplets. If there are microbes in that ocean, we could detect them. And NASA's Europa Clipper mission is on its way to find out. But Europa isn't alone. Saturn's moon Enceladus is even more dramatic. It shoots massive geysers of water, ice, and organic molecules into space from cracks near its south pole. When the Cassini spacecraft flew through these plumes, it detected hydrogen, methane, and complex organic compounds. The ingredients for life. Not only that, but the chemistry suggested active hydrothermal vents on the ocean floor. On Earth, those vents are teeming with life. So imagine what could be happening in the dark waters of Enceladus right now. Microbes drifting near warm vents, feeding on minerals, multiplying in the shadows. If life exists anywhere in our solar system, Enceladus might be the first place we find it. Before we go further, if you're enjoying this journey so far, make sure to like the video, subscribe, and turn on the notification bell. It helps the channel grow and ensures you never miss another deep space mystery. Now let's step beyond our solar system, because the search for life doesn't stop at the edge of the sun's influence. In fact, some of the most promising places for extraterrestrial life are orbiting distant stars. Over the past decade, astronomers have discovered thousands of exoplanets, worlds of every size, temperature, and composition. Some are scorching hot gas giants. Others are frozen airless rocks. But a few sit in the habitable zone, the region where temperatures could allow liquid water to exist. One of the most intriguing systems is TRAPPIST-1, a red dwarf star with 7 Earth-sized planets. 3 of them orbit in the habitable zone. Imagine that, 3 potentially habitable worlds in one system. If life evolved on one of them, it could easily spread to the others through meteorite exchange. The planets are so close together that you could stand on the surface of one and see the others hanging in the sky like glowing moons. If life exists anywhere around another star, TRAPPIST-1 is a top contender. But there's another world that has captured the attention of scientists around the globe, K218b. This planet is larger than Earth, with a thick atmosphere and possible oceans beneath it. The James Webb Space Telescope has detected water vapor, methane, and carbon dioxide in its atmosphere, a combination that hints at a water-rich environment. Even more intriguing, there are faint signs of dimethyl sulfide, a molecule that on Earth is produced almost entirely by living organisms. The signal is uncertain, but if confirmed, it would be the first potential biosignature ever detected on an exoplanet. Imagine the implications. A world 124 light-years away, with clouds, oceans, and maybe even life. But the search doesn't end with planets and moons. Life might also exist in places we rarely consider. For example, the atmosphere of Venus. Yes, Venus, the planet famous for its crushing pressure and scorching temperatures. But high above its surface, in the cooler, more temperate layers of the atmosphere, conditions are surprisingly Earth-like. A few years ago, scientists detected phosphine in Venus's clouds, a molecule that on Earth is associated with microbial life. The discovery is still debated, but it opened a new possibility. Life could exist in floating colonies, drifting in the Venusian skies, not on the surface, but in the clouds, alien microbes suspended in a world of acid and sunlight. And then there's Mars. The red planet has been the focus of life-searching missions for decades. While its surface is dry and barren today, we know it once had rivers, lakes, and maybe even oceans. The question is, did life ever take hold there? And if it did, could it still survive underground, protected from radiation? The Perseverance rover is collecting samples right now that could finally answer that question. If we find fossilized microbes in Martian rocks, it would prove that life can emerge on more than one world in the same solar system. And if it can happen twice here, it can happen everywhere. Halfway through this video, I want to remind you to like, subscribe, and hit the bell if you're fascinated by the search for extraterrestrial life. It helps the channel grow and lets me keep bringing you the mysteries of the universe. Now, let's explore the most mind-bending possibility of all, life that doesn't resemble anything on Earth. When we talk about life, we often imagine cells, DNA, water, and carbon. But what if life can exist in forms we've never imagined? What if it doesn't need water? What if it doesn't need carbon? What if it thrives in environments we consider deadly? Take Titan, Saturn's largest moon. It has lakes and rivers, but not of water, of liquid methane and ethane. The temperatures are so cold that water is as hard as rock. Yet some scientists believe Titan could host methane-based life using chemistry completely different from ours. Imagine organisms that breathe hydrogen instead of oxygen, that swim in methane instead of water, that build their bodies from materials we consider toxic. If such life exists, Titan might be the first place we find it. Or consider the possibility of life in interstellar space, organisms that drift between stars, feeding on cosmic radiation or dust. It sounds like science fiction, but some theories suggest that life could survive in the vacuum of space, protected by thick shells or dormant states. If that's true, life might not be limited to planets at all. It could be everywhere, floating silently through the galaxy. And then there's the possibility of technosignatures, signs of intelligent life. Radio signals, laser pulses, artificial chemicals, or even megastructures built around stars. We haven't found any yet, but the search continues. The universe is old, vast, and full of opportunities for civilizations to rise and fall. If intelligent life exists, we might detect it long before we ever meet it. As we approach the end of this video, think about what all of this means. We are living in a time when the search for extraterrestrial life is no longer a dream, it's a scientific mission. We have spacecraft exploring icy moons, rovers studying ancient Martian rocks, telescopes analyzing distant atmospheres, and scientists developing new ways to detect life in forms we've never seen before. The question is no longer, is there life out there? But where will we find it first? Before we wrap up, make sure to like the video, subscribe, and turn on the notification bell so you don't miss the next deep space exploration. And I want to hear from you. Where do you think we'll find extraterrestrial life first? Europa? Mars? A distant exoplanet? Or somewhere we haven't even considered yet? Let me know in the comments. I read every single one. Thank you for watching until the end. The universe is full of secrets, and together we're getting closer to uncovering the biggest one of all.